Once again, welcome back to this video tutorial. We can discuss about procedures in assembly language programming. While writing programs, it may be the case that particular sequence of instructions are used several times. So, in order to avoid these sequence of instruction writing again and again in the program, we can use the concept procedure or subroutine. Each time the sequence of instruction need to be executed, call instruction can be used. Call instruction transfers the execution control to the procedure. This procedure actually works as the function in C programming and method in Java programming. In the procedure, a return instruction is used at the end of procedure body. This will cause the execution to be transferred to the caller program back. So next is about the defining procedure or the syntax of defining a procedure. So assembler provides certain assembler directives like this proc, P-R-O-C and end P. These are used in order to define a procedure. Okay, so this is the general syntax of defining a procedure. Procedure name. This is a user defined name. We can use any name relating to our procedure. Next, we have an assembler directive proc. This indicates that we are going to define a procedure. Next is about the type of this procedure that is going to be defining. Okay, so this near and far type. Okay, so this is an example. Factorial proc near. Inside we have a sequence of statement. At the end we need to end the procedure using the assembler directive and P. So this is a user defined name. This proc indicate this is a procedure definition, and next this is the type of this procedure near, and at the end we have the factorial and P, end of procedure. This near and far actually indicate the type of procedure. We can discuss about this type later. Okay, next about this call instruction. This is used to call a procedure for execution. Before a procedure is called, the call instruction save the address of instruction which is next to call instruction on the stack automatically. So this particular stored information acts as the return address from the procedure body after its successful execution. Right? So before calling, before transferring the control to the procedure body, we need to store the return address. The return address is taken as the address present in the instruction pointer register. And this instruction pointer register actually hold the address of the instruction to be executed next, or address of the next instruction which is present sequentially next to the currently executing instruction. So store the current value of the instruction pointer register on the top of the stack, then transfer the control to the procedure body. This is the usual case. And we have two types of procedures like intra-segment or near call, inter-segment or far call. Okay, based on these type, we have two types of procedure, and we have these type of procedure like near or far based on the type of this procedure. Intra-segment means the calling procedure as well as the program in which we need to call the procedure. Both are present in the same code segment. That indicate an intra-segment or near call. And near call is used to call a procedure within the same code segment. That means the procedure we want to call and the program or the another main procedure or another program in which we need to use a particular program, both are present in the same code segment. So in that case, we need to specify the type as near call. And about this far call, a far call is used to call a procedure which is in different code segment. So inside a module P, we want to call a procedure Q, and this P is present in one code segment and Q is present in another code segment. Then we specify the type of that particular procedure Q as far, right? So For near call, it is clear that for a near call, both the module P and Q, the calling procedure and the called procedure, both present in the same code segment. So for a near call, we need to store only the content of instruction pointer register onto the stack in order to get the return address after executing the procedure body. Okay, but in case of far call, we need to store the return address based on the code segment value as well as on the instruction pointer register content. So we need to store these two values onto the stack top, because the procedure and the program or the module on which we need to use a particular procedure, both are present on different segment. So after completing the execution of the procedure called procedure body execution, we need to transfer the control to another code segment inside that particular code segment into a particular displacement position. So we need to save the code segment value as well as the instruction pointer register value onto the stack top in case of far call. Okay, so this is the case. This one indicate the near call. While calling a procedure which is of type near, then we need to store only the instruction pointer register content. Okay, but in case of a far call, we need to store both the CS register content as well as the instruction pointer register content. This is the case. Okay, so next about the return instruction. The return instruction is used to transfer the program execution from procedure back to the calling program. Okay, so after completing the execution of the procedure body, we need to transfer the control back to the calling program. Okay, so in order to represent that, we need to use a particular assembler directive, particular instruction RET. Okay, RET inside the procedure body at the end of the procedure body before closing the body definition. Okay, next indicate different types for passing parameters to procedures, like passing parameter using register, passing parameter by storing the value inside memory location, and passing parameter using stack. We can also use the pointer method for passing parameter, and these are the general method for transferring parameters to procedures. And we can discuss all this about the next program.